My name is Karl Schenzel and I'm a project assistant at the Institute of Energy Systems and Thermodynamics at Vienna University of Technology. And in the following video I would like to give you a brief interview about my project EDCS-Proof, Energy Demand Control System, Process Optimization for Industrial Low Temperature Systems. As part of the new Energy for Industry Innovation Alliance, the project has a total volume of about 1.6 million and a duration of about 3 years. Besides our institute, the consortium consists of 3 other academic partners, 3 industrial partners, the use cases, and 3 technology providers. As part of NEFI, the big picture goal is the decarbonization of industrial energy supply. In this project, especially high temperature heat pumps and thermal energy storages are addressed for process optimization. They provide the intensifying of waste heat utilization and integration of renewables. The plants get more flexible, but also the complexity increases. Having a look at the power market, the integration of renewables leads to increasing volatile supply. For balancing that, we come to the specific goal in this project. And this is the transformation of industrial plants to plannable, flexible consumers. Therefore, the energy demand control system was developed within this project. We will see that both the flexible plant as well as the advanced energy management and control concept in interaction are necessary to provide demand-side flexibility. Now we'll have a closer look on that, and we will start with the plant. In this project, the reference energy system was developed as a generalized, flexible energy supply system representative for this sector. So what's this system? It should represent the plant characteristics of the project partners' plants. Also, a literature research was done to get the information about best reference and available technologies within the sector. Moreover, new technologies as renewables, high temperature heat pumps and storages were integrated into the system. Mixing them together, we get following plant layout. It might seem complex on the first view, but let's structure it in detail. There are 5 different main energy carriers demanded by the processes. Talking about flexibility, on each level we have at least 3 suppliers that provide flexibility through energy substitution and sectoral couplings. Especially the heat pumps are a focus in this project. Moreover, energy storages are available on each level, providing temporal flexibility. Talking about control, it's about finding efficient and safe operation strategies for the whole plant. This is a quite complex task, considering the diverse energy demand of the industrial processes and the volatile energy prices and renewable production on the supply side. In between, there is the multi-energy system. Considering this, conventional control might not be the best option. And that's where the energy demand control system comes into action. And there, it's not only about finding a safe operation, but maximizing savings by exploiting all flexibilities. Let's have a closer look on this energy demand control system. There, mathematical optimization is used. To be more precise, mixed integer linear programming models are fitted into a modular component and energy balance-based structure. This gives the concept its reconfigurable character. The concept also allows a multi-layer controller structure. What makes it possible that the EDCS is an energy management system and a real-time controller at the same time. So the different layers can have different functions. For example, a long-term or short-term planner, a power supply optimizer, or just handling safety and risk. This is done simply by a different setup of the objective function. In the end, we obtain optimal trajectories for each component and thus for the whole plant. Talking about the development process. The EDCS is implemented in MATLAB. As we didn't have a laboratory with all those components, we implemented a simulation model as virtual representation of the plant in Simulink. And there we run a co-simulation. The optimizers in MATLAB deliver optimal control trajectories, so the control signals that enter the Simulink simulation model, and the system states enter MATLAB again as measured states. Coming now to a very interesting part. It's the investigation of the savings potential that can be achieved by the application of the ECDS to control the plant. Following the co-simulation procedure previously introduced, following optimal trajectories were obtained for each component. But to get an indication how good this operations scenario actually is, you need to compare it with something. And in this approach, a conventional two-point controller was chosen. This controller is applied to the plant within the same co-simulation procedure. And so operation trajectories are obtained for each component. Now both scenarios can be compared. Not going into too much detail, we can see clear differences between both scenarios. The different use of the various components can be identified by the respective colors. The chart in the middle shows a significant decrease in energy costs. The other charts show the distribution of energy supply and consumption by the different components. Summing up, we can observe a 23% reduction in costs, 20% reduction in energy use, and 60% reduction in emissions. I'll come to the end of my presentation giving a high-level comparison about several scenarios. Two control scenarios were already introduced. Then two plant scenarios, one with more flexible components. Moreover, three different periods. By comparing these scenarios, we can see that the one where the EDCS is brought to the more flexible plant is always the cost minimal one. Also, up to 30% reduction in costs, emission, and energy use can be identified. But having a closer look, it can also be seen that the cost minimal scenario is not necessarily followed by minimum emissions or minimum energy use. What might be a matter of pricing. I hope I could pick your interest. Professor Hofmann and me are looking forward to get in contact with you and discuss and explore these topics in more detail. Thank you for your attention.